Okay, we are back now with another stoichiometry sample problem, only this time we're going to be looking at a mass to mole problem. The way that you can identify that is simply by going to the question, which the question says, how many moles of chlorine are needed to react completely with 48.6 grams of sodium to produce sodium chloride? So we are given the mass of sodium, which is 48.6 grams, and our unknown is the moles of chlorine that we need to enter into this reaction. So because we start with a mass and we're being asked for moles, that's how we can identify that this is a mass to mole problem. And all mass to mole problems are going to be solved in the same way. So our first step, now that we've identified what's given and what's unknown, as with all stoichiometry problems, we'll need a balanced equation. So the question asks about moles of chlorine, that we are starting with sodium as well and producing sodium chloride. So that means our reaction is going to look like sodium plus Cl2, because chlorine is a diatomic element. We remember Hofbrinkel. So the sodium and the chlorine react to produce sodium chloride. And then we just need to make sure that our equation is balanced, which I'm going to quickly do. Right, so now we have two of each kind of atom on both sides of the reaction equation. So just like in the previous examples, this balanced equation has given us a molar ratio. So we know that 2 moles of sodium to react completely need 1 mole of chlorine to produce 2 moles of sodium chloride. Before we can actually set up our equivalent proportion though, we're going to need a value in moles, because we cannot do stoichiometry with mass, because mass doesn't tell you anything about the actual number of particles reacting. That's why we must use moles. So our first step is going to be actually to determine the moles of sodium. So we know that there's 48.6 grams of sodium in the reaction, and looking to the periodic table, we know that the molar mass of sodium will be about 22.98977 grams per mole. We know that those units of grams are going to cancel out for us to leave us with just a value of around 2.11 moles of sodium. Alright, so that's really good. We've determined how many moles of sodium are entering this reaction. Now we need to set up our equivalent proportion so that we can determine how many moles of chlorine we need for this reaction. So again, looking to the coefficients in this balanced equation, we know that within this reaction, to react completely, we'll need 1 mole of chlorine per every 2 moles of sodium. So that's how we set up our equivalent proportion, just like before, and then we're going to multiply it by the moles of sodium that we found. And I can double check that I've set up my proportions correctly, because I know I've set up my multiplier correctly, because moles of sodium as a unit cancels out, leaving us with only moles of chlorine. When you multiply the proportion in the blue box by the amount of moles of sodium we have, you're going to get an answer of about 1.055 moles of Cl2. And then therefore, we can just say 1.06 moles of chlorine are needed to react completely with 48.6 grams of sodium. So our first step there was we determined our given and our unknown. We wrote out our balanced equation. We converted grams of sodium into moles. We did that there. We set up our equivalent proportion to be able to determine moles, to actually go from the moles of what was known to the moles of what was unknown. And then we determined that value, and were able to therefore determine how many moles of chlorine were needed to react completely with a given mass of sodium.